that you need to know in the world of differential equations. First of all, I say differential equations, and the thing that you hear in your head is
Derivative.
derivatives, an equation that involves a derivative. It doesn't mean go find a derivative. It is an equation that involves derivatives. Now, way back in the day, we were looking at, anybody remember what these are called?
Slope fields.
Slope fields, right? These are fields of little tangent lines. Each of these little tangent lines is telling you how the curve behaves at a particular point. Sometimes, like on the free response test from Saturday, you had to make a slope field. They gave you the points. And then, David, what do? How do you make a slope field?
You go to menu.
Oh, not on the kit. You're giving me calculator steps. If I said, hey, go build a slope field, what would you do?
Oh, okay, so you get the equation, you start putting in the numbers that they do.
So you have your differential equation. They give you some points, and what do you do with the points?
Start evaluating.
You evaluate. God, I said plug in, you said evaluate. You're clearly the better mathematician. You're gonna plug in. You're gonna get the slope. And if the slope is, I don't know, +4, you guys show me in the air what you would draw. If the slope is +4, does everybody have a tangent line that's increasing? Wait, it looks like you're decreasing. Oh, yeah, you're right. Okay, slope +4. But what if I needed a slope of +1? +1, be careful. Steeper, shallower? Shallower, right? Doesn't increase as fast. Slope of 0? Horizontal. Slope of -1? We're decreasing. Undefined slope.
Oh, just take it off.
They're never going to ask you to do that. You are never going to draw a vertical tangent line. Yeah.
Oh, wouldn't you, if you're vertical, if you're...
Wait, you said vertical, but you're doing this. Horizontal?
Okay.
You will never graph a vertical tangent line. Ever. Slope fields, I think we're okay. One of the other things that you are asked to do is they would give you the differential equation, and oh, these are the money questions. They give you a differential equation, and then they say, go solve it. Have a 30-second conversation with somebody near you. What would you do? How would you solve this? Don't actually solve it, just tell them what you would do.
No, I subtract minus 2x, y.
Yeah.
So I times dx and then I'll divide y. So I can get the variables of y on one side and then x on the other.
Okay, so I've heard a lot of, I rewrite the equation, all the x's and the dx on one side, the y's and the dy's on another. Once you separate the variables, Christian, what happens next?
You have to find the derivative of both sides.
Not the derivative. The antiderivative, right? You separate the variables, it's over there, I got it. So you separate the variables, you go and you find the antiderivative on which side? Both sides. Don't forget your constant of integration. Next step?
Solve for the antiderivative.
You solve for y, and there's usually an initial condition, right? That was the big skill, and that's where I want you guys to get a lot of practice. But one of the hidden skills, and I just want to do this one whole group and then give you guys some time to practice. You guys might remember this, and I think maybe that you're going to have negative flashbacks. They don't give you the differential equation. They give you the words instead. Right, these tended to be the problems that this was no one's friend. Okay, the words are, let a of t be a function whose rate of growth is directly proportional to the amount present. What is the differential equation you would write? A is a function whose rate of growth is directly proportional to the amount present. I'd love to get some hands on this. I see Juan. I see Jonathan. I see Giselle. Jonathan, what would you do?
For directly proportional, it's not a k times x.
Okay, directly proportional means y equals k times x. K is a constant. Directly proportional, when one value goes up, the other one goes up by some multiplication amount. An example that I used to use before, you guys might remember my wife and I win the lottery, and we have not. Have you seen this polo? We've not won the lottery. Okay? I'm trying to keep it on the down low so that you guys don't know about this. Yeah, but we won the lottery. And for each one of you that gets a 5 or better on the exam, we're going to give you $10,000 towards college. The number of students that get a 5 and the amount that we pay out.
Will increase.
Right, the number that passed, the more we pay out. Is that directly proportional?
It sure is.
Right, one goes up, the other one goes up by like a multiplicative amount. The other example was inversely proportional. One value goes up, the other one goes down. Anybody remember the scenario for that one?
We pay you $10,000.
Indirectly proportional or inversely proportional? What's up?
May I get my
If you can do it really quietly, sure, Mariah.
Like the more people that get a 5, the less money you get because like that certain amount of money is being distributed.
Right, we had to change the scenario, and I said like instead of like $10,000 per person, we said here's like $10,000 to be shared. Right, and so like 10 people get a 5, 10 people share in that pot of money, and everybody gets less because of that. Still fiction, we haven't won the lottery. Okay, so let's set it up. Here's the important part, directly proportional. A is a function whose rate of growth. Last class really struggled with this idea. If A is a function, rate of growth. Don't call it out, don't call it out. Rate of growth. How would you represent in a calculus class rate of growth for this function? I see one person. I see 2, I see 3. Rate of growth. Juan, what would you do? I want to be careful. I want to stick to the right variables here. A is a function, and it's a function of t. So we're going to say, right, dA dt is directly proportional to the amount present A. So my differential equation is going to be dA dt equals k times A. Sometimes that might be it. They might just say, hey, go set it up. It's done. Now, I bet lots of you are going to be really comfortable solving it from here. Is that a pretty safe assumption? Mm-hmm. For those of you that are comfortable, go for it. Who are the folks that are going to do this with me? See what? Okay. All right, Eunice, what's your first move here? We've got dA dt equals k times A. Let me ask you a better opening question. How many variables here? How many variables? 2? 3?
Oh, okay.
3? 2? 2? Edgar, why 2?
K is a constant, so that's
K is a constant. Because K, it's called your constant of proportionality. So dA dt equals k times A. With separation of variables, there will be 2 variables. And you move all the A and the dA on one side, all the t and the dt on the other side. So let's do that with some legal math here. Multiply both sides by dt. dA equals ka dt. Haven't separated the variables yet because that A is still on the wrong side. Need some legal algebra. Divide by A. So dA over A equals k dt. And if this is free response, you just earned a point. We're going to integrate both sides. For the friends that are with me, at least one of these 2 sides needs to be recognizable for you. One of these is easier than the other. What do you see?
1 over A.
The integral of dA over A, or 1 over A dA, what is that? Natural log, be careful here.
Absolute value.
Natural log, the absolute value of A. Probably get a point for that. Jose, how do you feel about the antiderivative of a constant? With where t is the variable. It's going to be k t, be careful, plus c, right? You've got to get that constant of integration in there. Probably another point from there. Adriana, where do you want to go from here? Natural log, absolute value of A equals kt plus c. Right, we're going to do the E. Fancy word here? You're like, it's a secret. Right, we would exponentiate both sides. Not going to worry about the vocab here. E in the ln, Inverses, so we get the absolute value of A equals e to the kt plus c. And here's where you just need to be super careful.
Oh, I got you.
Edgar, what are you going to do?
Since they're under the same E, like
Yep.
the same, so you can say it's E kt.
E to the kt
No, times. I'm sorry.
times
E to the C
e to the c, and then our favorite thing to do,
is still C.
it's still, right, c is a constant, e is a constant that, you know, so e to the c, super Charlie, no need to draw that, but it's c e to the kt. I want to solve for a, and so this is where you say, oh, but a is plus or minus c e to the kt. C is a constant that I don't know. Is it positive? Is it negative? Don't know. It's a constant that I don't know. So we would say A equals CE to the KT. And depending on your needs, you're done. For friends that went by themselves, how many of you guys made it here? Good. Real quick before we wrap this up. You've seen this formula before. This is perfect. Right? This has the exact same form as PERT. You guys would use this back in the days of continuous compounding when everybody thought they wanted to be a banker or run a credit card company. And R stood for? Rate of growth. Always growth?
Rate.
It was rate. It could be rate of growth and then it's like positive, or it could be rate of decay and it's negative. T stood for? Time. A stood for? You're like A words, A words, A words. School appropriate A words. Answer, amount. And P stood for?
Principal.
Principal, also looking for school appropriate math P words. Yes, amount, principal there. Okay, great. Over here, K is your constant of proportionality. Proportionality. Your T is your time. The A is the amount. And the C is your principal. It's the amount at T equals 0. Now here's the really good news. For those of you that still have the brain space, the next time you see a differential equation that has this form, dA dt equals k times a, or dy dx equals k times y, or dp dt equals k times p, it is legal to go straight to the exponential form. You can skip all the calculus in between as long as you recognize the form of the differential equation. You can jump straight over here. But, much like Dora the Explorer would tell us right now, cuidado! Right? Yes, and that ends the Mr. Doja Speaks Spanish part of today's video. You've got to be careful. This only works, it only works if your differential equation is of this form that you can make the leap. It is a time saver. But if you do not have the brain space for this, just go through the process instead. Know what I mean?
So it would not work for inversely?
It doesn't. You would set up a different differential equation, which would be solved differently, and the model at the end looks different. But if you see this directly proportional format, jump on it. All right.
So that's the answer, the first thing?
The A equals CE to the KT, that's as far as we can go here. All right, all the friends okay? Okay, perfect. Enough talking from me. You guys have the next 10 minutes to get as far as you can on the next 3 multiple choice questions. Feel free to use your survival guide. You can get help from a partner. I'm going to move the camera just for a little while. There's a great looking conglomeration of teenagers back here. Don't worry, Jose, you're not going to be in the camera for long. Huh? You're not actually physically in the camera, no.
corrections that you need to make are all the way from the first row. Right, so these are all the questions I think somebody who's been through should be able to come with some help, right? You didn't miss all of them, right? You probably missed. Okay, that's what I want to go with. Andrew. Yes, sir. Right now, okay, I'm not gonna let you
I'll take one.
We've already. All right, multiple choice corrections. Multiple choice corrections. Multiple choice corrections.
Do you guys remember what we do?
Multiple choice corrections over here.
Sure.
Would taking until tomorrow give you the time to get this done? What I care about most is you're learning from the mistakes that you're making. Okay. Get it in the mailbox by tomorrow morning. Okay, multiple choice corrections.
That's true. Can we ask you for
In a little bit, I want you to sort it out and take advantage of the smart folks in front of
You just be like, but I told you it was this. I mean, like that. But you gotta do like that. When the variables are together like this, how do you say we separate them? So we can split them. Well, like if I did times dx, so look, listen, I did like times. So I did times dx on this side, so dx is right there, but I can't divide by y, so y is 0, right? Oh, now you want to say something?
because what you said right there.
So negative 2x dx, dy is negative. Because you have to subtract that,
Oh, and then it's L and
integrate that, integrate. It's gonna be, that's how they got here.
Just finish.
What's the answer?
Do you have a question for me? No. Okay.
I feel like it's A. Not A, right?
I thought it was B.
Either A.
Is that you doing okay there?
I'm doing 1.
Yeah.
How do I do number
Just a
one?
-1. For that I meant 8. I got the square part.
Just getting a different angle here. Trust me, I don't want to get my butt in there either. Okay.
I don't understand.
So what's your question?
I got that far, and I got, I don't know if it's E to
Okay. I think you're missing a negative sign somewhere.
How'd you get the 1 minus x squared?
You're working. Figure out where you so you subtracted from both sides.
E equals C, right?
You
Yeah, I got
integrate.
that too.
Okay, the integrating is good. So you've got natural log of the absolute value of y equals negative x squared plus c.
Because it's 2 times 1 half x squared. We mean by that it's just x squared.
If it
Yeah.
if it was negative c, like negative times c, that would be different. Here we're saying it's the negative of x
What do you
squared,
do after you get C?
and then you're adding c on it again.
And then when I get to that,
So you've got natural log of absolute value of y equals negative x squared plus c. Now you're going to exponentiate both sides.
That's already
But that it's I'm coming
to the negative x squared.
because of the negative x squared plus c.
So then it's c. Is it a?
I'm not going to tell you.
Because it's e to the first power plus c.
But you get negative x squared.
It's e to the first power times the whole to the x squared.
Oh, you're right. It is negative x squared. Yeah, my bad.
So we're good
You
here.
added them, so it's 1 minus x squared.
So
Yeah.
But my point is, where did you get?
You forgot to
so you get e
Where did they get the
over here
1 from? That's my
equals
question.
c times e to the 0. C has to be equal to e. So you're going to tell me that y equals e times e to the negative x squared, which is a great answer on the free response.
You don't you just added the.
But e times e to the negative x squared doesn't show up here. How are they hiding this?
Oh, it's e to the 1. They have the same e is the same thing, so it's a. They both have e as their base.
If you're
So
multiplying the
they're both
bases,
x
they're the
to
same.
one
You
and
have
e
the
to the
exponent.
negative x squared. So you combine the exponent. You don't multiply the exponent. You add or subtract them. It's a. Bro, I'm smart. No, because look, okay, you know that c equals
Friends over
e,
here.
so then it's e to the negative x squared, and then it's e to the 1. And you know, okay, so you know for exponents, like, you don't multiply exponents, you add them. So it's a. Wow. Brain fart.
Because I'm putting in the positive.
It's a number, so it's no one.
Okay, it's just a number.
Couldn't hear me.
So like if the
Said I'm
positive
sorry.
is negative, then the bottom, like,
Go to the next problem.
And that is a great answer. But you don't see it. So let's figure out. Okay. If this was free response, you are 100% correct. I want you to change nothing. This is a great answer, but they're hiding this answer. And the reason that the way that they're hiding it is that e times e to the negative x squared. And there's an algebra. What's the algebra? When they have the same base, what do you think it is? 1 times
Great.
add those exponents together, what do you get positive 1.
It's a negative 1. It's a negative
You're
number.
messing around with the algebra. Calculus, your calculus is just fine.
I need to look at them.
so for C, plug in
Oh, that makes sense.
the y value, then you know that for like the top half, it would have to be top, it would have to be negative, and it'll be equal because of the negative, and then the bottom half, the negative, it'll be positive.
This has to,
All right. All right, so I'm not going to tell you why it is the answer, but I think just about everybody has A for question number 1. You know, and A, question number 1, one of the things I like about this is like it tests your calculus and it tests your algebra. One of the things I don't like about this, it tests your calculus and it tests your algebra. On the free response, you guys are much more likely to get a question like this right because you're not going to bother to simplify. I want to make sure that if, God please, if there is a differential equations question on the exam next Thursday, that it is a place where like all 9 points rain down from the sky.
that one question could be what keeps you from a 3 to a 4. Yes, sir.
So if we recognize this pattern and we don't show any of that work, we lose points technically, right?
No. I promise you though, they're not going to show you this pattern on the free response. It's going to show up as a multiple choice question. And this is going to be one of those things that, like, if you happen to remember it, if your brain fires off in just the right way, at just the right time, you're going to save a lot of time. But they wouldn't put it on the free response. All right, so here's what I want to do. I need you to find a new friend, somebody that you are not currently sitting with. Choose wisely. And Edgar, we can still see you, son. Okay, what you are going to work on is free response model question on page 4. Find your partner and move. You don't need a calculator. You also have the right to say no if you are selected by someone you don't want to work with. All right.
Where did you say them?
All right. So here's what you're doing. Model question on page 4. Sometimes the College Board likes to take your skills with your differential equations and put it in a word problem. I will tell you right now, if you launch into, I know how to solve a separable differential equation, I separate the variables and integrate it, and it's the wrong time to do that, you won't get the right points. You have to know what to do and do it at the right time. So read this question carefully. We're going to check in 5 minutes. In the next 5 minutes, I'm going to help no human being in the room. You and your partner and your survival guide should work on the model question, page 4. The goal is to get all the way through parts A and part B. We'll talk in 5. Okay, Jose, I said it like 3 times there. Page 4, model question. It also looks just like the thing on the board. Thanks, Martyr.
This is the, what's it called?
Is this T?
The initial. Oh, really?
Everything is just one handed all the time. So we really deserve the float. But I don't do that. Maybe it does. They increasing.
So we're going to have to do this? So we'll know how much we do this.
Oh, God.
Nope.
Line tangent. Oh,
I'm just saying.
But the
That might be
number
important.
to gives you the total. Wait, this is the end. This is a rate.
Is it element?
That's what I'm saying. Like the derivative gives you the float. But W doesn't make sense.
This is the equation of the flow.
W is the waves. We don't need no T.
Yeah, because there's no. Can't we plug in 1400 for W?
Oh, you're never right. The definition again.
Because what I was thinking is like you could do, I don't know why you would do an integral, but I feel like you could do an integral from
Like the saddest way.
0 to,
Plus 1400 is
yeah.
Okay, good. So t equals 0, w equals 1400. That's your initial condition. That's also a point on the curve. The only thing you're missing
So will we plug in 1400 right here?
that's the thing. These two values go together. Here's the t value, and here's the w value. dw dt tells you about the slope of the tangent line at any point. So you're plugging in that specific. We're not actually going to do, you're not going to do fundamental calculus because they're not asking you for what is the actual value. You're going to do what Edgar's doing here. Because what they say specifically to do is use a tangent line.
Yeah, you just have to plug in because then you'll be so we do that.
Wait, oh, that's a okay. Sorry. Hi, friends. What are we doing? Why are you thinking about it?
I know you plugged in.
Plug in 1400.
Because you're looking for like the end of the first 3 months, so you can do an integral from 0 to the first 3 months.
Yep.
And then find that.
That sounds a lot like some like fundamental theorem of calculus thoughts maybe rolling around in the brain. And all that is great, and I love that. And the fact that you're thinking of apply now is a good thing. Except they're like, oh, they have told you how to do the approximation. They told you a very specific thing. They want the tangent, right? Use the line tangent to graph the tangent line. You have to do a tangent line here. That is the
We always call it LMX.
So then what you plug in,
Oh, that's 11, right? Yeah.
you plug in some, because what I was thinking is like the way you find
1100 over 100,
like this
that's
book that
11.
you just plug in the number here and then you would do that, you plug in
Alrighty. Alright, friends, the curse of this problem continues strong into last period of the day. This happened 3 years in a row. It's not an unexpected thing, but I really want to make sure I get full brain here, because this is the kind of thing I want you to be able to get all the points on. The important things that just about everybody identified, they're like, I know that when t is equal to 0, w is equal to 400, right? Some people even told me, they're like, I found the initial condition. Fabulous. Great. Abraham, what is it that we're actually trying to find here? The amount of ways that time t equals 4. So t is equal to a fourth, and what they're saying is what's w equal to? And I think what happened, and it's a good thing, and Noemi and Juan and I were just talking about it. You've got an initial condition, you've got dw dt, and they want to know the amount of waste at some time in the future. How many of y'all were thinking fundamental theorem of calculus? Like final value equals initial value plus total change? I swear I heard it at like lots of tables. That is a good thought. That is a good calculus thought. But the reason why we're not going to go that way is they have told you specifically how they want this estimate to be determined, which is with the tangent line. Last time I checked the equation of a tangent line, you need two things. You need a slope and you need a point. We got the point. The point is 0, 1400. What's the slope?
Find it.
You plug it into the differential equation. So your slope is dw dt. That's going to be 1 over 25. Now be careful. W minus 300 That's 1400 minus 300. That's the slope. If you want to simplify and do it, that's fine, but it's a waste of time. We've got the slope, we've got the point. The last thing, write the equation of a tangent line. Now, normally we were calling it L of something. Because the independent variable is t, I'm going to go with t here. I need to know my slope, so 1 over 25, 1400 minus 300, times t minus 0. Of course, you don't have to write the minus 0. Plus 1400, that's the first point. How many of you guys honestly had that as the equation of your tangent line? Okay, a couple of folks, not nearly as many as I would hope. Okay, here comes the easy question. How much waste at 1/4?
1411.
Yeah, 1411.
And that was a really scary answer to hear.
Yep.
Oh, it's going to be simplified.
I know. That's what made it so scary. All I care about is that W at 1/4 is going to be what I get when I plug in the t equals a fourth. If it's not calculator active, even if it was calculator active, no need to simplify. And yes, you're right, Edgar. 1411 tons. 1 point for the equation of the tangent line, 1 point for the estimate. I think, honestly, in the middle of a test, those are points I would hope that you would get now because we've had the conversation. All right, B. Tricky question here. In fact, I don't think most of you even had a chance to get to part B, so I'm going to get out of your way, give you another minute to have this conversation.
And W is what I'm saying is
So what's 300 divided by 25? That 6?
Well, maybe. Yeah.
Oh, you said it was y, right? Like y.
W is basically Y.
Because it's easier to do that.
And then the constant goes away.
What
Yeah, right?
I was thinking was to do
This is it?
the absolute, the natural loss of the absolute value of 25.
Why?
Wrong, because that's the anti-derivative.
Right, we're not talking about the
Oh, and then
antiderivative.
we
I
know
want
what
the
dw
second
over
derivative.
dt is.
So I need the derivative of this guy. All right, so most of the conversations at the table seem to involve d squared w dt squared. Jasmine, what does that even mean? D squared w dt squared. Means the derivative of the derivative. I want the second derivative. So what I need is I need to know what's the derivative, and I'm writing it this way with a very specific reason. I need the derivative of dw dt. And for those of you that stayed with me on Tuesday and we talked about implicit differentiation, you have an advantage right now. We're taking the derivative with respect to t, but w's the variable that I see over here. Right? If I'm going to take the derivative of 1 over 25 w minus 300 and option here,
Distribute the comments.
you could distribute the 1 over 25. You could even pull out the 1 over 25 because it's a constant. Last period, a whole lot of folks said, oh, let me do a product rule. Product rule, okay? Sure. If you want to use the product rule, go ahead and use product rule. Derivative of 1 over 25, 0. W minus 300 plus 1 over 25. Here's where we need to be careful. The derivative of w minus 300. The derivative of w minus 300. If w is the variable that I have, and I'm comparing it to how t is changing, the derivative of w with respect to t is dw dt. So we've got 1 over 25 dw dt. And although that's good, cannot write that as your final answer. Why? When you go back and you read the question, Adriana sees it, Edgar sees it, what's the thing? Why is this not going to count? Knowing me, why doesn't this count as the answer?
Because it's asking whether it's an underestimate or overestimate.
Well, we're definitely going to get to the underestimate, overestimate. There is a reason why this won't count as the answer. Giselle, why doesn't this count as the answer?
Because we know WDT. DWDT. You know
Well,
that.
we know
You can plug that
DWDT,
in.
but I'm saying that you cannot leave this as your answer. Abraham, what do you see?
Is it because it has to be in terms of only W?
Say that one more time.
It has to be in terms of W.
They are very specific, just like I am. They want d squared w dt squared in terms of w. That means w is the only variable you get to use. So don't use dw dt, get me to w. Juan, how are we going to get to w? Can't use dw dt. I wouldn't even find the antiderivative because you know something about dw dt.
Don't you already have that?
Right, you know what dw dt is in terms of w, so can you rewrite this expression for me in terms of w?
1/25.
1 over 25.
W minus 300.
Oh, no. Okay, dw dt. What's dw dt?
1 over 25.
It's equal to 1 over 25. W minus 300. This 1 over 25 is the 1 over 25 I was multiplying by to begin with.
Oh,
You got me?
yes.
This dw dt is equal to 1 over 25 w minus 300. Okay? We are not going to go any further with part B. Actually, here's what we're going to do. For those of you that are like, I am feeling the burn right now, I want you to move on to part C so you can leave here feeling good about yourself and your smarticle particles. Okay? C and D should be very comfortable and doable in the next 5 minutes. For those of you that want to finish off the conversation and have the underestimate, overestimate conversation, where are those folks? I see Ron Beer. Okay. Why don't you guys come on up here with your paper. Everybody else, finishing up part C, finishing up part D. Let's have the estimate conversation. Okay. All right. Okay. So we're okay with this, and knowing me, you're
I
eavesdropping.
just thought about it because
Okay. So that's your second derivative. They're asking you about, is your estimate, Jose, you're working on part C?
the number itself.
You're eavesdropping as well, okay. Can you put the cup back? Okay, the question is your estimate an overestimate or an underestimate? It's been a while.
Over 625.
How do we figure out overestimates and underestimates? You look at concavity, and the way you determine concavity is you look at the second derivative. There's a reason why they asked you to find the second derivative. Now here's the unexpected part. You've got to be really careful. When you talk about estimates with tangent lines, you need to talk about an interval. You need to tell me about an interval from your point of tangency, which is 0, all the way to the point that you're estimating. The point that we're estimating here is 1/4. So, for, what am I going to say? For this interval, 0 less than or equal to t less than or equal to 1/4. The point of tangency, the point that I'm estimating. My goal is to figure out the concavity. And this is not going to be a trivial conversation for us to have. If we knew that the second derivative was positive, then what about concavity? If the second derivative is positive, then that means concave up, tangent lines are going to be below, so your answer is underestimate. If your second derivative is negative, concave down, tangent line going to be above the curve, overestimate. The challenge though is this a positive number or is it a negative number? And you need to decide. Is this positive or negative, and why? Jose, what did you say? The function starts when w is equal to 1400, right? Giselle, you cool with what the homework is tonight? Oh, I didn't tell you guys what the homework is tonight. Homework tonight? No, never. Okay, all the multiple choice questions and free response question number 2. All the multiple choice and free response question number 2. If you're going to stay for the 2-a-day group, don't worry about that because we're going to take care of homework tonight.
Oh, yes.
All right, back to you guys. So on that interval, Jose, you said we start off and w is equal to 1400. Now, is it always equal to 1400? It's not always equal to 1400. In the beginning, if w is 1400, 1400 minus 300 is positive, times 1 over 25 times 1 over 25 is positive. But what happens after t equals 0? What happens to that w value? Right, and Edgar, you guys are working on part C, right? What happens? How do you know that? Right, what we know is that w has to be greater than or equal to 1400 because w starts off with 1400 tons, and way in the beginning, so long ago that you probably forgot, they said w is increasing. So if w is greater than or equal to 1400 and it's increasing, then what do we know about the second derivative? Hold on, second derivative.
So wouldn't the
Second derivative
w over dt
is positive. Right, the sign of the second derivative is positive. If the sign of the second derivative is positive, w is concave up, and then your conclusion.
Oh, okay.
Therefore, an underestimate. Now, for the friends that were just working on part C, real quick. Part C is worth 5 points. Gosh, how unfortunate. There's all that writing on the board right now. Okay. So, part C, separate the variables by dividing by w minus 300, get a point. Integrate, natural log, absolute value, w minus 300. Integrate on the right, 1/25 t plus c. Exponentiate, do your little super Charlie thing, use the initial condition, 300 plus 1100 e to the 1 over 25t. How many of you guys honestly made it to 300 plus 1100 e? Okay. Tonight's homework is all the multiple choice and free response question number 2. If you're doing the 2-a-days, we're starting in 5 minutes. Get out of the room. Go for a walk. Smoke them if you got them. Still don't know what that means.
Stop it. I gotta go smoke Ruben.
All right.
I thought we had a race.